Hello, I'm Tally and welcome back for our microbit session on servos. So I will start this like we have the previous ones with asking the question, what is a servo? I've got a picture here of a servo straight out of the pack. You might think it looks very much like a motor, and that is something that we shall have a look at as to what makes a servo unique. So you can see it has like a propeller-like blade on the top that can be used to spin and attach components to, so we can have different things attached to it to turn. You'll also see that it has the cable connector as well, which if you're being eagle-eyed, you would already have figured out is not going to connect to your microbit, and we will also have a look at that before we start the programming. What is the difference between a servo and a motor? Well, a motor is something that makes a wheel go round and round. If you look at the motor on the right, you will see it only has two cables coming out of it, unlike the three wires in the servo. The reason is a motor has an on and off. It's either spinning or it's not spinning. Whereas a servo is different. We can actually program the servo to turn a set amount. We use degrees, as in degrees of a circle, to work out where we want the servo to position itself to. The average servo will do 180 degrees. That is a half circle. So like this, we could program the servo to go to any angle between the 0 and 180. Now these images are taken from the MakeCode simulator that we will be using in a little bit to show you how to program it. Now obviously you could choose to go anywhere between those angles. I've already mentioned the odd connector on the servo. The reason for this is that is sort of like a standard connection for other microcontrollers, not like the microbit, but the Arduino or a Raspberry Pi or some other computer that will go into the center of your programming system. Now we are using a microbit, and as you know, the only thing we have to attach these things to are pins. So you can see on the right, there's one that I have modded up myself. So what I've done is I've separated out the three wires, removed the connector, and instead I have attached three new wires that are color-coded to the microbit that have crocodile clips on the end, which will allow them to connect to the microbit pins. So now we can program it with a microbit. Now, what I've done on the color coding is so I know that the black goes to the ground pin, the red goes to the 3-volt pin, and the yellow is the programming clip. So that goes to the pin that we're programming. So if you are going to buy a servo and you end up with something like this and you want to use it with a microbit, you will either need to have a look at getting some sort of breakout board or some sort of extension to your microbit, or you'll end up modifying the servo like I did there. That is something that we'll look more into when you're doing the electronics topic, which follows on from the microbits. Okay, so programming the servo. You know where the extension library is after our last session when we were looking at NeoPixel extension. This time when you go to the extension menu, look for this. It's the servo library. And this gives us a whole range of new blocks, and it puts the servo into the simulator like we saw in the angle pictures that I had. One thing you do need to know is that the servos that we'll be programming are positional servos. They will be using the positional blocks that are in that menu. What that means is that the servos have a limited range of angles, and as normal, ours have a range between 0 degrees and 180 degrees. They cannot turn all the way around. They can only do that half circle of angles. There are, just to let you know, there are servos out there that can go the full 360. They act like motors, but they are motors where we can control the angles that they rotate at through programming should we wish to. These are called continuous servos, and those blocks there are for them. So we'll be looking at exercises that use the positional blocks, not the continuous. One key thing about servos is a word called calibration, which means that we have to set the servo to a set angle. We have to do that manually, or we have to write a program that will make sure that the servos are set to correct angle before we start using them, so we don't try to move them to a position that they are not lined up to be able to reach. That is sort of something that you can look up online if you are looking to use a servo yourself on a microbit. Most servos come with instructions. Some even come with programs that can do it for you. And in some kits, if you've bought a kit for your microbit, you may already have a little circuit board included that you plug in to the the controller, whether it's a microbit or some other form of controller, that will automatically straighten all the servos. The other calibration that we need is quite often in the program, where we have to let the program know where the starting angle is. If you don't want the starting angle of 0 to be where it is on the simulator, you want it to go from pointing down to pointing up and just spin on one side, then you have to calibrate or set that inside the program. Don't need to worry about that. This session's exercises are all based around a standard left to right servo from 0 to 180. So let's check out the walkthrough.
So I've opened up my big simulator. I've written a little program that uses the servo to demonstrate a couple of things. So the first thing I want to demonstrate is the turning. So at the moment, the automatic setup is it will set the servo to the 0 degree mark. So you'll need to tell it at the beginning of your program on start where it is that you want it to position. I like it at the 0 because it makes it easier for me to see which direction it's going to turn in. Okay, so I have this bit of code here. This is my blocks for my servo. If you notice they're here, this is what I was on about. This is the positional block. This is the only block that we really need to use when we're using a positional servo that's 180 degrees. Continuous blocks, as I said, they're like motor blocks. You've got speed rates and you've got stopping it. And then we've got some configuration bits. Now, we don't need to worry about these because the configuration is if your servo has a different range. Now, ours has a range of 0 to 180. We're happy about that. So we don't need to use this block. But if it was a 270 degree or you wanted to use the other half of the circle and calibrate it that way around, you'd need to use this for 180 to 360, for example. So what I've done is I've quickly put together this program here. Now this here just has it on 4 times. Now what I want it to do is I just want it to go from one side of the servo to the other side. I want it to go quickly switching like a windscreen wiper backwards and forwards. So I've done this and I've got it on my simulator. So when I press button A, it will do its program. Oh, what happened? Well, that's not doing what we expected it to do. Why not? Well, you see, what we've got here is very, very quick instructions. There's no time for it to actually get to 180 before it tries to get back to 0. It's going, oh, I've got to go 180. No, I've got to go to 0. No, I've got to go to 180. I've got to go to 0. It's too fast. It can't actually make the movement. So we need to slow it down a bit. Now, how could we do that? So I've brought across a slightly different bit of code where I've put some pauses in. So now I've told it to go to 180 degrees, which is on the other side to where it starts, then give it 200 milliseconds to do it, and then move it back again. Let's see how that works. Back into the simulator. We press get it all set up. There we go. So on button B now. Oh, well, it's getting a little bit further, but we still haven't given it enough time. And actually, what we really need to do is slow it down that bit further. So what I'm going to do is I'm going to slow it down to a second between. There we go. Here we go. So we now have our servo and we're now ready to go on button B. Oh, look, now it gets all the way there and back again. It's even got a little bit of time to pause. Now, the thing with the simulator is, of course, this is set on a sort of average servo. So you still need to run these tests on your own microbit if you were to use a servo on it.
So hopefully this session has given you a good idea as to what a servo is, what a servo looks like, and how to program a servo for use with a microbit. Hopefully you now set up that you can go away and have a go at our exercises that go with this session. And we look forward to seeing you in our last session on the microbit topic, which will be microbit remote controls. A little bit of a refresher on how to communicate between microbits in a way that allows you to create a remote control. So hopefully we'll see you then.